Okay, this is a basic overview of what I've been working on for the past. It took me about 30 hours to get to this point. Cumulatively, it was a project. So this is it. It's basically just a little arrow, two stepper motors that turn what they call azimuth and elevation towards the International Space Station. It can really point towards anything, anywhere, but right now it's currently set to point towards the International Space Station. So everything is currently running on a Arduino Maker 1000 Wi-Fi. So because it has access to Wi-Fi, it means it can run completely, well, autonomously, battery operated. I don't need to plug this into my computer or a wall or anything. I can take this anywhere, really. So as long as it has that Wi-Fi. So let's get it started. So all the code, everything is programmed into here. And on this chip, there is a program that runs basically this little server. I created a little web server address. And hey, you can see me too. How are you doing? And this is it. So right now, the ISS is in idle mode and it's not tracking. And the A and Z are 0. That means that everything is zeroed out. So you see our little compass. Right now, south is this way. So this ISS tracker points towards it's supposed to be true north, but I have the coordinates messed up, true south. So it points directly towards south. Now it is zeroed out, it's oriented, and we can start. So how it works is, now that the pointer itself is zeroed out, all I have to do is press this track button, and it should go, there we are, tracking equals true, and give it a second. It just moved, you missed it, but there it goes. It works in increments of 10 seconds. So every 10 seconds, it updates the coordinates of the International Space Station, where it currently is. So this is the current azimuth and elevation of the International Space Station. And it adjusts in real time. And a few other key functionalities of the website is it has, well, a few different modes: track, idle, park, roam, and zero. So once you set this manually, you have to turn the motor to true south, then you can zero it out, then it's oriented. Roam, it basically just is a little feature to make sure that the motors are working correctly. So it just rotates it and rotates the azimuth, the elevation, I apologize. Park, it basically sets the motor and it goes right back to 0, 0. Idle makes it stop, and track makes it track. So we can press park right now. I'll press it in 3, 2, 1. And you can see it just goes right back to 0. We can set it back to track. Now it'll continue going on its way. So hardware-wise, I tried to make this as minimalist and basic as possible. So there's no buttons, no switches, nothing. The only thing that this has is, well, the two stepper motors themselves. Each stepper motor is connected to a motor controller, and the motor controller hooks right onto the Arduino itself. And this one wire is just ground. And the whole thing is powered by this power bank, 5-volt power bank, that supplies the Arduino with power, as well as the motors with power. So these are the two, this is the positive and negative. These clips just basically connect these wires. Yeah. So everything is running as minimally as it possibly could be. The rest of it, all the interface, all the UI is really run through the Arduino itself. It connects to my Wi-Fi. I gave it the Wi-Fi name, SSID, and password to my Wi-Fi so it can connect to it. And from there, it's able to pull data from the internet as to the live location of this, as well as it's able to upload this server, basically, a mini server, its website, through the IP address of this Arduino. And a couple of fun facts. The ISS actually travels around the world a lot quicker than you would think. It takes around 1 hour and 30 minutes for the International Space Station to make a full orbit around the entire Earth. So right now, the International Space Station, we can see, it should be, based off of this, somewhere maybe in India, around that longitude. Oop, I'm off. It's by China, in the middle of the Pacific Ocean still, or just about to be. And the And that's exactly where it is. So it's pointing directly towards it, obviously through the Earth's crust and everything. Yeah. So I think it's just incredible. I'd highly recommend you guys watch the video by Practical Engineering. I sent it in the group chat earlier. It was just the total motivation for me, drive for me to do this incredible project. And he is just an incredible, he explains this in a lot more coherent and concise way. Okay, and as for 3D modeling, this was quite the project. This took me about 13 hours to do alone. I have zero experience with 3D modeling, so I had taught myself Tinkercad and learned to 3D model myself. So basically, this is 3 different iterations of it. It was previous iterations, just learning the physics of Tinkercad and how everything worked. So for example, this was a imported model of the exact motors that I'm using here. I even ended up printing one out just to make sure that things would fit. Oh, the camera's not focusing, but this is the motor. And then I ended up trying to click everything together. And then each thing is connected by, I'll show you. So if I press space, I can run the simulation. And gravity is here. I can press WASD. W and S moves around the azimuth, and A and D moves around the elevation. So with this, I went through a few iterations. This one's tied down. I can now basically 3D model and design the entire project. Yeah, make sure it actually works before I actually 3D print anything out. So I wanted to get all the directions right and make sure that the rocket didn't touch the base. That was an issue. I made sure that the motors would connect it properly. It's having a little bit of issues right now, but it was working perfectly normal before. It was just good. This is a big part of the design phase of this project, getting these motors to work and making sure that this is actually 3D modeled and designed properly. So then it actually surprisingly came out well, the first print. I had previously tried to use 3D AI to try to, I had to describe it with the 3D model that I wanted, and then it would print it out for me. And it came up with just pretty bad results. This was like the base plate of it, and I had zip tied the motor onto it. It was just very janky, and the AI could not do at all what I wanted to do. It's just not there yet. So I did most of this by hand. The 3D models of the motors themselves were pulled from online, but other than that, this was, I cut holes into things, make things fit. I designed this all myself, put the motors on. It was quite the process. 3D modeling, learning 3D model for the first time was not as easy as I thought it would be. 1010% worth it though. But that was the 3D modeling part of this project. And the last thing I could talk about here was the code itself. Admittedly, this is the part I probably did the least out of everything. AI really handled the majority of the code, and the code is still far from perfect. There's still much more improvements that I can make upon it. But this is it. It ended up being in total around 1,112 lines of code. It is definitely a lot more bloated than it needs to be. I do have some basic coding knowledge to know that I can make this a lot better, and then that is part of the goal. But this is something that thankfully took the least amount of time, but also I understand the least. So it's something I definitely want to get more into, to learn more about coding. But this is what's running behind in the background. All of it uploaded inside of this little board. It is incredible what the technology can do. Next, I wanted to talk about rooms for improvement. So there is a lot of room for improvement, the code being one of them. But what I really want to do next is really design an actual enclosure to make this actually neat and organized and pretty. So what I want to do is this could be the lid of it, but I want to design a box that this lid can maybe slide into. And then all the electronics would fit neatly underneath it, and so it would be one concise little unit, one box, one compact box. I want to hide all of the electronics inside of that box, so all you see is just the outside exterior of the 3D printing of the model. This did not finish 3D printing, but it still holds the motor, so I'm using it. This is not the prettiest. there's definitely a lot I need to improve on in general, but that is something that I really want to go forward with. I really want to learn more about 3D printing and 3D modeling, because this is a skill I think can be just so useful for so many everyday tasks in your life, if you know how to do it right, and there's just so many applications for it. So that would be next. Alright, and that's basically just a brief overview of what I've been up to, this project. It has been quite the journey. It has been a lot of time sunk into this, but I learned so much along the way. I learned about just hobby electronics and wiring and voltages, just so many minute details. I learned about 3D modeling, of course. I learned about code. The electronics, hobby electronics, is something I definitely did not, I had like almost very, very little, close to zero experience with. And I learned a lot about how to wire electronics and to get things to actually work together, to actually function, to get Arduino talking with the motors and the motors talking with fuck the internet. So it was quite the learning journey. Happy to share it with you guys. I hope you guys, I guess, find it as cool as I do. Yeah, it was much fun watching these videos I did making it. It's been quite the journey. It's been awesome. But yeah, until next time, stay smart. This is Daniel signing off. Should I be a YouTuber? Alright, bye.